This is Dr. Vyasram. So in the QU board, we have used several examples and we also implemented 5 case studies in the previous session. Let us discuss few more case studies related to this robot. So in this example, we would like to use the bottom 3 infrared sensors, which are there below the robot, which are mainly meant for line follower. In this example, we will use only one sensor where you are supposed to draw a black line on a white surface, on a white tiles, so that this robot will follow the black line. Because whenever the robot moves on a black line, the sensor will give you, line follower sensor will give you, infrared sensor will give you 0 value. If it shift to the white area, white surface, it will give active high state. So let's write a program to sense the line with the help of the bottom center sensor, and based on whenever it is line is detected, till the line is not detected means it should hunt. Basically it should hunt for 0 1 0 1 0 1. That means actually it is as if following the line. Okay, so to begin with, what we will do is we'll start with LCD initialization, saying that press SW1 on the first line, start in the second line, and let us enter into some conditional while loop, saying that the switch, right, whether it is pressed or not, this is SW1, right? So if SW1 is pressed, then this loop should be terminated, while loop. It will go to the next instruction. In the next instruction, let us display on the LCD saying that it is following the line. Okay, wait for 1 second delay and move the left motor forward with a speed of 10. After that, enter into infinite loop. Now, within infinite loop, again, let us have conditional while loops, saying that look for bottom center sensor is equal to 0 and also look for bottom sensor is equal to 1. So let us use two conditional while statements, one for 0, one for 1. So that means it is actually hunting the line 0 1 0 1 0 1. So as if you are moving on the line, you are coming out of the line. You are moving on the line, you are coming out of the line. So then with a delay of 10 milliseconds, now you move the right motor forward speed with a 10 and left motor stop with a speed of 0. Then after some delay of 20 milliseconds, left motor forward speed of 10 and right motor with a speed of 0. So this is in short what, and then again go to step number 5, means infinite loop. So how the code actually looks like, let's try to compare this code. Okay, this is switch number 1, example number 6, or you can say project number 6, called single sensor line follower. So what we said is, to begin with, we said initialize the LCD, saying that press SW1 in the first line, initialize again the LCD displaying start in the second line, write a conditional while statement saying that whether the switch is pressed or not, till then wait for that, and once the switch is pressed, come out of the loop and on LCD display following line and wait for 1 second delay. And now the motor, left motor to begin with, let's say left motor forward with a speed of 10. I mean, try to keep this vehicle on the line wherever you have drawn the black line with a tape, electrical tape. You can draw it on the surface of the tiles. You can paste it and then put the vehicle on top of the line so that it will hunt the line. After that, so once the vehicle started moving towards the left side, then you enter into the infinite loop. Now in the infinite loop, what we are doing is we are verifying, right? Bottom sensor 0, if that is means we are looking for 0 state for the bottom means below the PCB infrared sensor 0, and also we are looking for 1. So it is actually basically looking for hunting for either 0 or 1. So if this condition is satisfied, any 0 or 1 shifting like a square wave, then wait for 50 milliseconds, then right motor move, because earlier you are moving towards the left, now you are moving towards the right motor forward, and left motor stop, and then again you are verifying for the same means the same condition. Only thing is this time it started moving towards the right side. Then verify whether the 0 or 1 the sensor has detected the line or not. Once that shift occurs, then opposite side, left motor forward and right motor stop. So basically you are hunting the line for 0 and 1, and then whenever you comes out of the line, right motor forward. If you come out comes towards the left side, left motor forward. So it's basically hunting the line with the help of a single sensor. All right, so if you want me to demonstrate, actually this while loop should be while following sensor condition should be here also, right? That's at both the places where we are saying when while loop. Only our difference is once we are saying right motor, here we are saying left motor. In both the cases, we are verifying for the condition, while condition, right? So let me demonstrate actually how this is functioning. So here you press the SW1. Once the SW1 is pressed, now it is actually the bottom center sensor is hunting, but you can see the tilt part, left, right tilting based on the sensor's position is a high state or low state. All right, so on our system, these sensors, the three line follower sensors are here. In this example, we are looking for the center one. All right. So if you compile and program it, so on the LCD, whatever you have mentioned is displayed. Then press the SW1, this switch. Now the system will start. Again, you will notice on the LCD, following line message is displayed. Now it is looking for the sensor, the center sensor. Accordingly, the vehicle will start moving either left side or right side based on the where exactly the bottom center sensor is positioned. All right. I hope you have the motors and it will follow the track. Example number 7. Example number 7 is again a line follower. Only difference is this time it is using all three sensors. As you can see, bottom center, bottom left and bottom right. So you look for all three sensors, and to follow the line, let me quickly explain the code. Initialize the LCD saying that press switch W1 in the first line, second line display start, then look for switch to be pressed. If the switch is pressed means 0. If the switch is pressed, wait for a delay for 10 milliseconds, terminate the while loop, and then on LCD display following line. After that, enter into infinite loop. In the infinite loop, we are verifying if conditions. Bottom center, first, if the bottom center is 0, if this is there, then the vehicle start moving forward with a speed of 7. Else, now you are looking for two more sensors, bottom left and bottom right. If bottom left is detected, then you should move towards the right side. So that's why right motor forward with a speed of 10 and left motor should be stopped because you want to tilt it, and buzzer should be on, delay of 20 milliseconds, buzzer should be off. If bottom right sensor is detected, then you are supposed to tilt towards the left, right motor forward with a speed, right motor should be stopped with a speed of 0, and buzzer should be on with a delay of 20 milliseconds, buzzer should be off. Else move motor move forward motor with a speed of 7. In any case you want to move towards the forward because you are actually on the track. If you are shifting out of the track, then you will be getting, the sensor is detecting the high state. Otherwise, if you are on the black strip, the sensor is giving the low state. So if you are on the track, then you will be moving forward. Otherwise, if you are tilting either left or right side, the vehicle on its own is tilting, means stopping one motor, switching on other motor, so that either it will left turn or it will be right turn. Otherwise, move forward, else move forward. That's how the program works. I hope you understood what is the concept of line follower. There is a black line, draw it on a tiles, and then if the infrared sensor, the bottom infrared sensor is placed, the light will be reflected, infrared light will be reflected. If it is a black strip, then light won't be reflected. If it is a white, light will be reflected. So now in the program, you are creating a conditions saying that whether the value is 0 or 1. That is a bottom right, bottom left, bottom center. If it is actually on the track, value is 0, so move forward. If by any chance if you are getting 1, that means you have turned either left or right, then move the motor exactly the opposite side. If it is going out of the line, again turn left, or if it is going towards right, toward left, turn right. If it is in the center, move forward. So these are the three steps where a motor has to be left, right, forward. You want to take a decision based on the left sensor, right center, sensor center, whether their values are 0 or 1. I hope now you can verify this program and see how it's working. All right. So this is about the example number. This example is to move the robot to a specific distance, right? If you want to travel either forward, left or right to specific distance, then how do you know, how do you measure the distance? So since the robot has backside two infrared sensors called count sensors, left wheel count, right wheel count, whenever the wheel rotates, it will cut the light. You can see the wheels are having some gaps, right? It's not fully covered. So whenever the light falls, it actually, when the vehicle moves, it actually cuts the light. So you are verifying whether the wheel is rotated, how many times it has rotated or not. So what we do is we initialize the count, right? Right motor count as a 0, And on LCD we will display the how much distance it has traveled. So saying that, for example, press SW1 and go 1 meter on LCD. Let's display this message. Then wait for the SW1 switch to press in the conditional while loop. And once you press that button, then again on LCD display saying that going 1 meter, and wait for 500 milliseconds, and you enter into while loop with a condition. What is the condition is count for less than 77, which count your right motor count. Till then, move the vehicle forward with a speed of 7. As and when the count reaches 77, then stop the motor speed, means terminate the while loop, and on display, LCD display, say that 1 meter is complete. Alright, so this is how it goes. So example number 8, distance measurement. What you can see is, as I said, first initialize the variable. This time right motor count. What we are interested in, the variable is right motor count, and initial value is 0. And on LCD display, first line is press SW1, 2, and the second line display go to 1 meter. And in the while condition, this time look for a switch press, whether the switch is pressed or not, 0, look for 0. If the condition is satisfied, it will wait for a delay of 10 milliseconds, and the conditional while is terminated. On LCD this time, now you just display saying that I am going 1 meter, and after some delay of 500 milliseconds, again enter into while condition. Now this while condition is for what? You are counting, basically the condition is right motor count less than 77. So this is the count you are looking for. Till that period, till that right motor count reaches 77, the motor, move forward motor with a speed of 7, it should move forward. As soon as the 77 reached, means as good as 1 meter distance it has traveled. I mean, that's a calibration. If you find some wear and tears are there in the vehicle, it's unable to travel due to some various reasons, friction or the battery power and so on, then you should adjust the count accordingly. So the count should be in such a way that it should travel actually 1 meter. Once this condition is satisfied, stop the motor, and on LCD simply say that 1 meter is completed. That's all, program will be terminated. Like I demonstrated earlier, let's see the video. The uh, vehicle has a encoder in the back side. So that is actually basically started counting. This fellow has started counting. There is a sensor. Now it will move exactly 1 meter distance and it should stop. So that's what you need to verify, that actually it is accurately counting or not, right? So you can see there's one sensor here, there's a left side, there is a sensor, right side there is a sensor. So if your wheel is placed here and here, actually it is cutting the light. Okay, now if I put my finger, you see the light is on. Okay, if I put this side finger, the light is on. That means actually it's cutting the light, wheel light. So the counter is counting accordingly. All right, verify how much distance it has traveled, and then if there are any problem, you in the program you try to change the count value, right? So this verify count is nothing but your right motor count. Right motor count less than 77 till the move the motor forward direction. All right. So that follow our main means you have 3 front sensors, and whenever you keep your hand in front of the sensor, then since you have the motors, right, you fix the motor, left motor, right motor, and there is a dummy wheel. So if there is a, for example, front center, if you keep a front center, if you keep your hand, then the vehicle move forward direction. It should move forward direction. If you keep your hand towards the right side, then the vehicle should move towards the right side. If you keep your hand towards the left side, then the vehicle should move left side. That's the concept. So three front sensors and the vehicle motor should be moving towards wherever your hand is there. That's the, problem statement. Now, if you look at the problem statement, how it is defined. So first on LCD, display first line, press SW1, second line start. After that, in wait for loop, right, conditional while loop, where SW1 switch is pressed or not. Because in all the robotic practicals or the projects, we are not starting the vehicle unless switch 1 is pressed. The reason is, see, if you don't, before you do something, it may start rotating. Then it may unnecessarily create some problems. It may start hitting the objects and so on. So once you keep everything properly ready, then you press the switch number 1 so that the vehicle will start moving. That is the reason where our program is not switching on the motors immediately without pressing the switch 1 in every program. Alright. So as soon as you press the SW1 on LCD displays following the hand, and wait for 1 second, and now you enter into the infinite while loop. There in the infinite while loop, check for use if condition and look for the center sensor. If the center sensor is detected, that means if some obstacle is there, your hand is there, then move the forward motor. Otherwise, if again, that means else if front right sensor is detected, then move the right motor. Else, if front left sensor is detected, left motor should start moving the left motor with a speed of sorry, there is a mistake, with a sorry, this should be speed of 0, and right motor with a speed of 7, right? So say finally it has to tilt left, right, forward. If none of the three things are satisfied, else stop the motor with a speed of 0, wait for 10 milliseconds, and again go back to the step number 4, that means infinite loop, where all three if conditions are verified. So if you look at the program example, example number 10, that is called hand follower. The hand follower, as I said, first initialize the LCD, first line display one message, and the second line display some other message. Now use the while, conditional while, look for first switch to be pressed. If it is pressed, this loop will be terminated. It will come to the next line. The next line we said LCD display some message saying that now it is following your hand. Then wait for some delay. Now while 1 is a infinite because there is no condition here. It is a true. While 1 means 1 is always true. So in true condition, in the infinite loop, three if conditions, if loops we have created. First if condition is, we are looking for, of course you can use several sensors. If you remember, you can use whichever is the sensors you want. But now we are looking for front center, right? Front center sensor. If this is detected, then motor, which motor? Move forward motor with a speed of 6, because it is center. So we want to move the vehicle forward direction. Else if front right is detected, then what we should do, right motor stop, left motor forward with a speed of 7. If front left sensor is detected, then left motor should be stopped and right motor should be forward with a speed of 7. If none of the if conditions are satisfied, just stop the vehicle and again go back, and if delay, and again it will go to the while 1 statement. So that is how it will look for these three sensors, and the front sensors. This time it's not the line follower, it is the front sensors. And if you keep your hand, the vehicle is started moving towards your hands direction. That's the purpose of implementing this project. All right, so you download the program and verify. I'm sure it will work as we have verified in the past. Example number 11. Let's have a more complicated example. In this example, let's mix both. One is line follower. It should be following the line, as well as it also should verify any obstacle is coming in front of the vehicle or not. That means it also should continuously check whether any object, that means where you use the front sensors, front center, front left, front right. We have bottom center, bottom right, bottom left. So can we mix both the sensors? Let's see how the program goes. You should start your own algorithm, draw the some diagram how the program should work. Accordingly, you write the program, modify the program as per your logical thinking. Let me brief you about the program. So to begin with, initially same, we have mixed two programs. One is LCD is initialized, saying that first line is so and so message, second line is so and so message. In the conditional loop, while loop, we are verifying have you pressed the switch SW1. Till then wait for switch to press, nothing will happen, system is stopped. If the switch is pressed, then on LCD following line is messaged. Okay, now it is enter into infinite loop. That means it is keep on executing this loop again and again unless you switch off the robot or press the reset button. Okay. So in the infinite loop, while loop, what are the conditions, if conditions? First if condition is bottom, right? Bottom center. If bottom center is 0, that means what? That means that your robot is exactly on the center of the line. 0 means what? The black track is there, so it is giving the 0. So move forward. That means the vehicle will start moving forward. Else, else means what? That means it is not in the center of the line. It may be on the left side or right side. So now verify, oh, it's not in the center, then what? Bottom left. If it is on the bottom left, what does it mean? That means the vehicle has moved right towards the left. Means it's away from the black track towards the left. So what should be your action? Exactly opposite side, move right side. So since the bottom left sensor is detected, then what are you doing the motor? Right motor forward, right? So you are moving towards the right side and left motor stop. That means actually it is a turning towards the right side because you have stopped the left motor and right motor forward. Then you said buzzer on, delay, buzzer off. All right, so this is done because see it won't be executed for a longer time because the moment if you shift towards the right side, this condition won't be satisfied immediately. So the once for just for no whenever bottom side is there, then only this motor will move towards the right side. For example, the bottom right sensor is 0. That means what? Say for example, your vehicle has detected on the right side sensor has detected. That means the rightmost side of the sensor is on the center of the line. Right? So that means you have tilted towards the right side. Naturally, you are supposed to move the vehicle towards the left side. So the left motor should be forward and right motor should be stopped. So that means now it will turn towards the left side because you have switched off the right motor. The buzzer is on, delay is on and buzzer is off. Now, alright. So these are the hunting conditions for the line follower left and right. Alright. And then you have another conditional loop, right? So the first if condition is already done, right? But then we are again, since it is an infinite loop, in this loop only we are verifying one more condition, if condition. What is this? This is not the bottom sensor, it is a front center, right? So in front of your vehicle, let's say for example any obstacle is there. So that what does it mean? It means now you cannot go forward direction because obstacle is there. It may hit, the robot may hit the object. So what you are doing, oh, if front center is detected, is active high state is detected, then you want to enter into some conditional verification while while loops, while conditional loops you have verified. What is the condition you are looking for? That is, in the loop also again you are saying whether the front center, right, sensor has become one or not, right? Or the bottom center sensor is one or not. Otherwise, then what you are doing, you are turning left towards a left direction because see, since some object is there, you do not want to go move forward direction. Instead of turn left, you can also turn right. It is your choice. Or you can tilt to 180 degrees. Means it will exactly will be, see, when you keep on turn left, it may turn to 180 degrees because you have given a delay of 10 milliseconds. Instead of 10 milliseconds, for example, if you give 5 milliseconds, the turn left may be not 180 degrees. It may be 90 degrees. It may be 45 degrees based on for how much time. See, two factors are deciding the your turn. One is the with what speed you have turned left. Second is how much time the turning is on. So you adjust the delay, you adjust the speed, then you will understand the turning left, turning right uh, uh, is that angle is decided by these two factors. All right, so while doing this, you are also verifying the bottom center. Means, are you still on the center of that track or not? Because you do not want to deviate from that. All right, so that is the one more condition we have added in the infinite loop. One is to keep the vehicle on the track. Second is to verify any obstacle is there in front of the vehicle. If it is there, then we want to turn the vehicle towards the left side with a tilt angle of 10 milliseconds of 5 speed delay. Then verify what is the angle you are getting. All right, so these are all the things which you can adjust, calibrate, change the direction as per your wish. So far we have explained more than 10 examples. So I didn't write any algorithm, but I wish you write your own algorithm and accordingly implement, and not necessary that you have to as it is implement this. You should change the tilt angles, you should change the speed, you should change the direction. You should also change the conditions, that what is the condition you would like to satisfy based on these three sensors front side, three sensors bottom side, and distance measurement. We have also seen the two sensors on the back wheels, the distance measurement. So that is the counters, right? The wheel counters, right? Motor wheel counters. So that is also you can use. You can also use the LDR, right? Light dependent resistor to follow the to check the intensity of the light. Then you want to take some action. So far, these are the sensors we have extensively used in various case studies. Then we will see that TV infrared remote sensor also, so that QU board UART serial port is connected through USB port, as we have discussed in the earlier sessions. In the device manager, we have seen how the computer is connected to the QU board. It is giving some port number. So that means we are communicating serially to the QU board. In future, instead of serially cable, we can also put some Bluetooth, Wi-Fi, Zigbee, various wireless communication devices. So more or less the program is same because all these devices are communicating serially. Okay, so instead of using TV remote, right, infrared remote, this time we are connecting a cable and we'll connect to the computer and control the robot with the help of the computer keys. If you press the keys like A, S, D, W, then A for turn left, S for move forward, move backward, D for turn right, W for move forward. So these four keys of the computer should control the robot, the direction. So how do you do that? So what we do is, if you remember the UART program where the QU board has a serial terminal. So initialize the UART with a new line with a baud rate of 57,600. Then on your computer screen through UART, display W for forward, S for backward, A for left, D for right, so that user understands that these are the four keys he or she has to press. And now enter into the infinite loop. In the infinite loop, first define the variable UART input, because you have to continuously read any key is pressed from the computer side. Now use the if conditions of UART input. If UART input is equal to A, then you turn the left motor with a speed of 10. Else if UART input is S, then move backward with a speed of 10. Else if UART input is a D, then turn right with a speed of 10. Else if UART input is W, then move forward with a speed of 10. So these are the four possible keys you have defined. The ASCII values the computer is continuously sending to the QU board. QU board will compare any of these four keys are pressed equivalent ASCII values. If the comparison matches, then corresponding motors will be on. If none of the four conditions are satisfied, the motor should stop, and again you should go back to step number 2 in the infinite loop. Alright, so a slight modification as compared to previous example. In the previous example, we have used TV remote, IR remote, to send the key values, and accordingly we have controlled. This time it is a wired communication where computer through wire USB cable we have connected to UART of the QU board, and we are controlling it. So instead of motors, you can also use some other components like LEDs, buzzer, LCD, so that if you press any specific key, the corresponding action should take place either on LED or an LCD or on the buzzer. So that way also you can say that through computer you are controlling. Say for example, Sarigama Padanisa, right? Say for example, if I press some key, then the buzzer should say Sa, Ri, Ga, Ma, Pa, Da, Ni, Sa, like that. Or on LCD display, if say specific key is pressed, some message should display. B is pressed, some message should display. Or an LED, if one key is pressed, once it should blink. If I press second key, twice it should blink, and so on. So there are several ways you can verify remotely, like the way we have done TV remote. Similarly, through computer keyboard also, you can control the QU board. Let's look at the program. The last and final program which is provided right now, but after that you are supposed to create your own case study. So PC controlled QU board. So in this program, a slight modification as compared to previous program, where this time we are not using the variable from the IR remote. This time the variable we are using is a UART input. Alright, so let's see the flow. First UART, we will display some message saying that PC controlled QU board. What is the baud rate we have selected? 57,600. And then insert a new line so that the next message will be displayed in the next line. Then what is the next message? We are saying that W for forward, S for backward, A for left, D for right. So that message will be displayed on your computer terminal. Then infinite loop while 1. Now the variable we have defined means we would like to store is UART input. So that's what we are interested in. And once the value is when you type some value through your computer keyboard, now the conditional statement. Now this time which if statement we are using, you can see UART, this one. So that conditional statement we are verifying if UART input is double equal to A, because now the operator is equal operator, and UART is, now you see we are putting in the quotes. Why A you have to put is because it's a character. So character means ASCII value it has to send. So we are comparing for the ASCII value A. If that is satisfied, then left motor will be on. So this motor, instead of motor, you can also put LED, buzzer, LCD. It is your choice. Similarly, else, or instead of A, you can also use other keys. I mean, only thing is the comparison should be same at both the sides. Else if condition. Now, if you press S, then this action will take place. Else if you press D, this motor will be turned right. Else if this is done, this thing will takes place. So you can keep on adding else conditions. Finally, if none of them are satisfied, probably you want to do nothing, stop the motor and terminate the end if, because else has to be terminated. So end if as else if has to be terminated. And after some delay, again since it is an infinite loop, it will be keep on executing. So though I have not connected the motors, but what happens on your computer terminal, I can show you. So let's program it. Now the programming is done. Now if you, what you should do, go to tools and say terminal. Now in the terminal, what is the baud rate I said? 57,600. You should select it. Now clear the console, nothing is there. Now the next thing is connect to QU board. Here it should say connected to QU board. Now you see on the console the message as displayed. This message is coming from the QU board. Whatever you have written, what you said, PC control QU board, W for forward, S for backward, A for left, D for right. That's what you did it. Alright, so now what is the next step? You are supposed to send some, means on your output, right? Here output, you should supposed to press WSAD. So whichever is the key you press, then the corresponding ASCII value will be transmitted to QU board. Then the motor will start rotating accordingly, right? So if I press W, right? Now you can see I have pressed the W key like that, or S key. So you can type those keys and send to the QU board. Then you will find the corresponding action there. That's what it will takes place as per your logic. If you are interested in displaying a message back to you, then instead of motor, here UART message also you can put it here, so that whenever you press a key, again it will send back to the computer terminal saying that, oh, you have pressed this key, you have pressed that key. That way also you can do it, so that it will send back to your message because you have pressed a specific key. So verify either on LED or an LCD or in buzzer or on the motors that whichever is the key you pressed, the action should take place. Or the other way around is, instead of doing all these actions, on the computer terminal it said it should echo it back saying that, oh, you have pressed this key. For example, you type A, then it should display a message apple. Then you typed B, then it should say ball, C, cat, like that. So you press something, then the QU board should reflect it back that, oh, you have pressed A, then I am giving you A for apple, B for ball, C for cat, D for dog, like that. So that way also you can verify, understand what do you mean by bidirectional communication. In this program, it is unidirectional because you are only sending the commands to the QU board. But QU board also can send some variables back to you by putting in the conditional loops that for that key I am giving corresponding reply. You can do that. Alright, so that's the final case study. I hope you can also implement, like I was keep on saying, various possible examples. I already explained several new ideas, new problems. You can also think of it. So before I conclude, right, what I said is, if you remember, this final assessment, what is expected from every participant is, before I certify that you have successfully completed this course, First is you are able to connect the QU Robo on your own, and you are able to install QUBot Visual Lab software and also device driver. You are able to connect the QUBot to computer and then open the existing programs, and every program you are able to load it and run the program, and you understand as per your program uh, the action is taking place on the QU board. That's what is we expect, that at least you should know what is happening. After that, able to modify the components values. It's not that only running the programs. Every component has its attributes. You can see the left side of the window. So those all the possible conditional statements, variables, right, operators, logical operators, you should be able to add, delete, modify, compare, all these things you should be able to do that. This is the meaningful way of understanding any language, because right now we are not bothered about the syntax. What we are trying to understand is how the high level language is converted into a machine language and how the CPU responds based on your set of instructions. So that's the reason why initially we are using the graphical language instead of a text-based language. Then you should be able to add new components and new conditional statements. You know there are total 5 types of components are there. You should be able to use almost all the components while writing your own codes. Then able to create a new program, means fresh, everything fresh, just new. Then start adding one component at a time, and then you should be able to compile and verify the results. You should be able to use all the components. No component should be left while creating the new programs. Now implement a new project. See, after doing these 13 plus projects, we expect that also given some new ideas. You can also have your own ideas. Write a algorithm first. This is what I want to achieve. Put it on in your own words, whichever is the language you are interested, Telugu, English, Marathi, Hindi, whatever. Then equivalent blocks, you should select it here and then compile it, download it, verify it. Then write a small report, because see, finally report writing, documentation, giving a presentation is also important. So we expect that either prepare your own PowerPoint presentation or a Word file, create your own report, and then we expect that you should give a demonstration as well as explanation, right? So for that probably you may require some slides, some typed document. So create your own report, and once you are done with your all exercises, uh, we would like to see your leadership qualities. What is a leadership quality? Leadership quality means when a group of people are there in front of you, then how do you present yourself? How do you dress yourself? How do you speak to the people in front of you? With what is your body language? Then how confidently you demonstrate step by step if of concept to the demonstration. Everything is a learning for you, because in future wherever you go, whatever you do, whichever is the job you take up, whichever is the career you take up, these are all helpful for you. That's why we expect that let's take some school children from local schools and invite them, try to enroll them. I mean, it's also learning for them. So you should act as a mentor, right? You are now the trainer. By the time you complete this course, you should become a trainer. If otherwise, once again, there is a possibility that you have doubts, you are not confident. If you are not confident, then do it yourself again till you are sure your concepts are clear. If your concepts are not clear, then what will happen? If you go to the next language, then again you have a doubt in your mind that how do they work, how do they behave. Then the other languages are slightly tougher than the language which you are using right now. So that's why we expect that first, while using this language, your concept should be crystal clear, no doubt at all. So that's why repeat it 10 times, 20 times. But when you explain with that full confidence, you should explain the program. So that's the beauty of it. Like any product, what is the success of a product? If you are able to sell it. So if you are demonstrating to some students, and if they are enrolling, if they are joining, if they are happy, they are giving good feedback, that means you are successful. That's the thing which is the end results. All right. So while doing all these things, we also do the online sessions. So we expect you, every individual student, able to use the Google Meet, share the screen, right? Share the presentation, share the code, show the board how it is working, right? Audio, video. So all these day-to-day tools, generally we use it for demonstration, that you should demonstrate it remotely also, because nowadays most of the companies are also working online. When companies are working online, work from home or remotely, then without any hassle, right, you should be able to demonstrate all these tools and technologies which are available for online purposes. There is another tool called AnyDesk or Remote Desk or Remote PC. So these are some softwares which will allow you to remotely control the laptops or computers. Say, for example, right now in my place in Mumbai, I am sitting in a lab. Now I have my computer connected to a QU board. Now from remote place like Wellanki, can you control this robot? Or the other way around. Now, for example, I am the client and you are the server. Now to your system, a robot is controlled. Now from Mumbai, I would like to control the robot which is at Wellanki. So how do I do that? So there is a software called AnyDesk or Remote Desk. Even Windows has this software. By using that software, we should be able to remotely control it. So I expect even this software also you should practice it, so that by any chance, if you want to remotely demonstrate the hardware or any programs where you are at one place, but however the system, the robot successfully completed the coursework. Like I was telling that what do you mean by AnyDesk? So there is a software online available, or in the Windows also this remote PC is available. So AnyDesk you can download, and after installing this software, there is a, on your top side of the screen, left side, code generated, right? Left side is this thing will be there. So the client PC will require, see, for example, if I am the client, I require your computer's code. So through your mobile phone, you should tell me that so and so code is generated, right? So if you pass the code to me, then through my PC, I will enter, right? Where I will enter, there is a enter remote desk ID, alias, this thing is there. I will enter from this side. Now, once I enter it, then you will get a message that the pop-up message will appear asking to grant the permission. Then if you give the permission, that's all. After that, I will be started controlling your laptop. Say, for example, if you install this software, right? So you can see this icon, AnyDesk icon will appear. Right now you can see on the top screen where this address, for example, I am the client, so my system address is 670.428.112, which is a unique. Similarly, you will get this kind of a unique ID. You should pass it on to me. Once you pass it on to me, then I will try to connect to your system, right? Then you will get some message will pop up to your side. Then if you give permission, then I will start using your computer. That's how it goes. All right. So with this, let's conclude the coursework, whatever so far we have done about the QUBot graphical GUI based software we have done in these 14 sessions. Thank you. Bye bye. Take care.